All right, hey folks, we got here. This is slide 11 that I'm going to go through right now. So obviously we didn't have time, didn't come close to it even for group share outs here, but I still want to go through it because this is where I'm going to give you the formulas. I'm going to do it here, okay? Be prepared to share a strategy, observation, or question with your team had while solving for perimeter in areas of regular polygons. Take notes on the sketch and in the text box here. So in your textbook, they go through this with you, but I'm going to kind of go through with you right now. A regular polygon, we want to come up with a formula, okay? Regular polygon here. We want to do three things. Of regular polygons, we want to come up with a perimeter formula. Well, that's pretty easy, okay? And we want to figure out an area formula here, okay? So anyways, the problem with what they gave you on this one was they gave you the radius, and that didn't help with either. So let's maybe draw out, I don't know, a regular polygon. Here, regular polygon, equilateral, also equiangular. So maybe I'll do this. See how many shapes we end up with, sides we end up with. Let's see, I'd go a little wider here. Okay, a little wider here. Let's keep going. And it's hard to draw. So anyways, I'm going to stop now. Okay, I'm going to stop now. This is looking really messy. Maybe I'll undo some of it because it looked really messy. Maybe I'll stop here, okay? So what I'm going to call this is I'm going to call this a regular n-gon, okay, n-gon, okay, here, right? When you look at these formulas, n, what n stands for is the number of sides, okay, number of sides. So here in this particular problem, with the different ones we did, think about what you did. How did you get the perimeter of the hexagon? How did you get the perimeter of the pentagon? How did you get the perimeter of the octagon? Well, here, each of those shapes has a particular number of sides. That's what their n-gon is. Penta is 5. Hex is 6. Oct is 8. So that's it. Number of sides here. And in order to get the perimeter, we simply needed to take the number of sides, okay? Number of sides. So this is the n-gon. We got our number of sides here. And we needed to multiply it by, well, regular polygons, equilateral and equiangular. So the equilateral thing tells us that we have one particular side length here, okay? Side length here, okay? So that's our second kind of parameter that's part of this formula, okay? This letter that's going to appear in the formula, the letter S represents the length of one side of the regular polygon, whatever that regular polygon is, okay? So perimeter, number of sides that regular polygon has, which you should know because you're given that in the problem, right? It's going to be hexagon, octagon, pentagon. Okay, number of sides to get the perimeter. Well, all you need to know is the length of one of those sides. Because we're equiangular, multiply by the number of sides that we have here, okay? So here we go. Perimeter formula is perimeter equals n times by s, okay? N times by s. And there we have it. We've gotten to a formula. Hopefully, you can see where that comes from and you can accept it, but I think that is a proof, right? Is a proof here, okay? Perimeter is defined as the sum of the lengths of the sides of a polygon, okay? We know because it would be given to us that it's regular, all the side lengths are the same. So all the side lengths are the same, take the length of one side length, multiply by the number of sides, boom, proven for you. I would consider that to be a theorem right there, not just an assumption, okay? I think we kind of proved it there. Okay, another theorem for us here is going to be the area of a regular polygon. Check this out. You didn't have to do this today in today's lesson, but this would be an easier way to get the area here. Okay, so remember that a regular polygon, one of the takes away from lessons here is that a regular polygon, okay, should have a center. Okay, this is the center of the regular polygon. Okay, it has a center point, regular polygon. Another thing, I've heard that word center before. You have, it's the center of the regular polygon, but because it's the center of the regular polygon's circumscribed circle. So any regular polygon you can inscribe in a circle. Thus, you can have a circle circumscribed about that inscribed polygon here. Remember, inscribed means inside. So this is a regular n-gon. It's sort of just generic here. I didn't try to draw it so it wasn't an octagon clearly. Maybe it's a nonagon. I don't know. But anyways, we're doing this here. It would have a center here. Okay, have a center point here. Okay, because that center point, the thing you were given today was the radius. Okay, the radius of the polygon here. So I'm going to put that down. That's actually not going to appear in your formulas. But R, when you have problems like this, when you see R, what that is going to represent is the length of the radius of the regular polygon, okay, which is the same as the length of the radius of the regular polygon's circumscribed circle, regular polygon. And in order to get the formula for this, radius isn't super important, okay? But for the actual length here. But I could draw a radius in here. This is my radius right here. This is my radius right here. And the reason why, as you learned today, radius is not that important is because this is a triangle. Those are simply just sides of the triangle, okay? And remember, area of a triangle is 1/2 base times by height, okay? So this is what you need to know. This is the new thing here, is that S, that's side length, N number of sides, R radius. I think you can accept that. The harder thing to remember is this, is that the thing, you use the radius and you use the angle measurement you found using trig. You then used, angle measurement you used using the interior angles of a regular polygon formula, okay? Then you use trig because if I have an isosceles triangle, and this is, right, that's side length R, that's side length R, I can introduce an altitude here, okay? If those two things are congruent, I have two congruent triangles by HL, okay? I can figure that angle measurement. I can use trig to figure out how long that is. And this is lovely here too, because here I got my A right here. I'm gonna mark it A, that's what I'll call it. This here, if we had to re-show this, let me show this right here. Let me redraw it around, okay? We got this. This is that little triangle that we see there. I can figure that area of that. Okay, I can at least come up with a formula for the area of this here. Because this here, look, I got my R here, I got my R here, I got my S here. Area of this triangle isn't 1/2 R times S, it's not that. It's 1/2 base, which is S, times by height, which you're used to seeing as H, but we leave H for the figure itself, okay? We don't care about the height of this n-gon, we care about the height of its triangle, okay? So what that is called here, right, the height of the triangle here, right, from the center of the regular polygon to one of the sides, the distance, right, the perpendicular distance here. This is always perpendicular. Okay, that is going to get the variable A, and that stands for apothem. That is a crazy word. I don't remember learning that at all in high school. My husband was when he became a geometry teacher, and I was like, wait, what? Should I know this apothem thing? And Mr. Tran had to be like, it's actually pronounced apothem. I'm like, all right, cool. Okay, so A equals, I'm going to do that in a different color. Might as well do that in a different color when we haven't had yet. A equals apothem. Equals apothem. There we go. If I know the apothem of a regular polygon, a regular n-gon, that's just the perpendicular distance from center to any of the sides. They'd be the same because you prove all these triangles congruent. Then I can get the area of this little triangle right here. So to get the triangle, the area of the isosceles triangle, well, it's just 1/2 A, right? A for the apothem times by side length. That's it here. Okay? So to get it for the whole n-gon is this. Okay? What will we have to do here, right? I have 1/2 AS for each of these triangles here. To get to the whole, so regular polygon, okay, I would take this 1/2 AS and what would I have to do to it? Okay, if I'm trying to derive a formula for the area of a regular polygon, okay? I would have 1/2 AS, right? That's the same thing as 1/2 base times height. So the base of this triangle is the side length of the regular n-gon, and A is the height, right? So base times by height, 1/2 of it. What am I gonna have to do to get the whole thing? Well, this gets me one triangle. How many of those triangles are there in this n-gon? Okay, n-gon is just a generic idea. Well, I see 1, 2, 3, 4, but how many sides are there? There are n sides here. So what I would have to do is simply multiply this by the number of sides we have, okay? So I'm gonna give you two formulas for the area of a regular polygon that you can use. Perhaps you're given these attributes of the particular regular polygon. But here we got 1/2 a times by n times by s. Here I just switched the order of this. That's called the commutative property of multiplication. If you're multiplying things, order doesn't matter. Okay, so I wrote it this way here. What do we notice? What do you notice here about these two formulas here? My dog's going nuts. He loves regular polygons here. What do we notice? Wait, I see n times s there. I see n times s there. Okay, so here we can replace this, okay, because p equals n times by s. I can take this and put p into here to get a more simple formula. Okay, so here's how you do it. Here's the fastest way to figure out the area of a regular polygon. You take 1/2 the apothegm, okay, apothegm, again, that's the altitude of one of these isosceles triangles, and you multiply by the perimeter of the figure. And there we have it. We got to two different formulas for the area of a regular polygon here. And hopefully stay with me with this. Nice work today using trig, making connections that if we just didn't do that in class today, you wouldn't have those connections to rely back to, okay? It's something I couldn't have taught you, right, in 15 minutes time, wherever it is here, okay? So excellent work. Maybe add this formula to your little toolkit here, okay? And that's that, all right? Your little toolkit for area formulas, okay? Thanks for watching, guys. Take care. Bye.